Technologies. I am doing this internship based on embedded system, and during this internship we have built a project based on MPLAB XIDE simulator on the software called PixSim Lab. We worked on the project that is micro-oven simulation. This project is built by three members. I am B. Shweta and Banu and Supriya. And here are the contents of the topic is topics what learned during internship, requirements and what is the micro-oven and microcontroller and microprocessor, PixSim Lab, CLCD, matrix keypad, ISR, timers and project implementation. And topics learned during internship: introduction to C language, arrays and pointers, functional strings, storage classes, conditional loops and operations, introduction to embedded system and microcontrollers. We have also learned about how to use MPLAB XID and how to compile the help of XC8 and how to simulate on PixSim Lab. Introduction to various peripherals of 16F877A. We had attend so various quizzes and attend also this workshop. And here are the requirements to do the project: MPLAB XIDE, XC8 compiler, PixSim Lab, PIC16 F877A, 164 CLCD, MKB, timer, tactile switch and project implementation. And coming towards the micro oven. A micro oven is an electronic oven that heats and cooks food by exposing to it electromagnetic radiation in the microwave frequency range. It is embedded system interfacing with external environment by means of various sensors and actuators. There are mainly three modes in this micro oven. There are micro mode and grill mode and finally convection mode. Let us discuss about one by one. First, micro mode. Micro mode. This mode is used to cook food in traditional way. It uses maximum power of 900 volts. In this maximum time that you set for cooking 60 minutes. And next one is grill mode. This mode is used to cook meat and bread. It works as the micro mode, but the purpose is to cook and bread. User can set time as per the cooking time of the meat. And final one is convection mode. This mode is use can set the oven to preheat per a particular temperature, and it takes 3 minutes to preheat the oven. After preheating is done, then the user can set the time as per the requirements. What is meant by embedded system? Embedded system is a combination of any hardware and software which is intended to do a specific task. A general purpose is used to perform large number of tasks, whereas an embedded system is used to perform a specific task. There are some types of embedded systems. There are standalone system, real-time system, networked and mobile. Let us discuss about one by one. Standalone system is in this standalone system there are two types: slave system and independent system. Slave system is for not intelligent even though these are embedded systems. This system cannot take action by their own, but independent system can take action by their own. Example like Google Car. Real-time system. These systems are time-bound system which while take action on a specified time, failures in this system are not acceptable. Example like we are using in mainly in car airbag system. Network system, the system which are connected to the network. Example like home security system. Mobile system, the system which are movable or called as mobile system. Example like we have all seen that robots. And now Microprocessor and microcontroller. Micro Microcontroller is designed to do the specific task, but the microprocessor is to do all the different tasks by arranging components in an integrated circuit is capable of being programmed to perform a specified task. It has design restrictions such as memory size, input output capabilities, peripheral functions, etc. Choose a microcontroller based on applications, performance, price, availability of tools, and special capabilities. Microcontroller. All components will be in a single chip. In this microcontroller, it has less flexible and less design complexity, but by microprocessor, all components are assembled separately, and it is more flexible than microcontroller and more design complexity. This is the architecture of the PIXM lab. CLCD. CLCD stands for Character Liquid Crystal Display. In PIXM Lab, there are two types of display. One is 16:2 and one is 16:4. It displays the ASCII characters and some special characters. It is not commonly used display. There are two types of communication modes. There are 4-bit mode and 8-bit mode, and this is the display of the CLCD. MKP stands for Matrix Keypad. This is a keypad in which a number of tactile switches are connected in row and column concept. This is used when number of user inputs are required and still wants to save some controller input-output lines. These keypads are mostly common used in telephone calculators and digital locks, etc. ISR stands for, next is ISR. It is interrupt service routine. An ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag that should save register contents that may be affected by the code in ISR. And now come to timers. Timers an important in an embedded system, which is a default peripheral which maintains the timing of an operation in the sync with a system clock or an external clock. It has many applications such as measuring time, generating delays, etc. Timer counter is a software designed to count the time intervals between the events. And this is the screen will appears which about the power on, and it is the display of power modes. This is the micro mode. I told earlier that we have set the maximum power timer at 900 watts. We can set the timer accordingly. In this one is convection mode, and this is the after setting the timer it will give us the option to start. This screen will appear as so. Can we press RB3 button at a present here? Also the screen will appear as RB3 button. Thanking you. This was all about the project. Now we will see remaining simulation and code in MPLab.
Hello everyone, I am Banu. Now let's see the code. So this is the code which was written by 3 of the members, that is Sweta, Banu and Supriya. First of all, we have included all the libraries which is required. Then we have provided all the types of variable initialization. And we have initialized the module that is required. We can see it here. Here we are using the while loop to mention the project which specify different conditions. So for example, if press key 1, then what should it display mentioned over here? Then press key 2 will show it should display over here. So for all we have written it. Also we have using switch case to determine all the conditions. All the cooking modes in it. We also declared all the functions that is required in the main file. Now coming towards the end. So everything is mentioned in a while loop. So that our code will run continuously coming towards the main file while all the prototype and all the modules required. Now let us build the project, see what's the output. So as we can see, the build test successful.
Hello everyone, I am Supriya. Now let us see the simulation in PiximLab. I will load the hex file. So as soon as I will load the hex file, the power on microwave screen display, this known as CLCD display. Here is the fan as shown as we switch on the any mode. So here 4 modes are displayed. As soon as we switch on any mode, the cooler or the fan will run. So we can choose any button and it will display the output. So buzzer is here, that's why it's not working. We will press buzzer, it will start working. So as you can see, first we choose the convection mode. I am getting the option to enter the temperature. Set the temperature. You can give any number. You can clear with the help of starts and enter with the help of enter. So we have give 180 seconds preheating time. That was set. It was set to 3 minutes, so it will go on. So you can reset at form here. You can do the reset. You have by mistakenly press the preheating mode. You can reset it from here. Again power on screen will be generated and you can give the command and would like to press any button and mode or that in micro mode you have to press or before button, then you will get all the 4 options. You can choose button that will generate the code. So this was all about the microwave that we have generated. I would like to thank the Emertex Technology for giving us the opportunity for build such as project, and we like to thank you the mentors for guidelines as this internship.